All right, guys, today we're going to learn about inequalities, and this is something that we've learned about before. It's something you guys have talked about in third, fourth, and fifth grade, but now we're going to kind of put a little pre-algebra twist on it and solve inequalities similarly to how we solved equations last chapter. So let's take a look at our notes. We're going to fill them out together, and along the way, I'm going to have the video paused, and you'll have to answer some questions about what you've learned. So make sure you pay attention and fill out the notes as we go along. An inequality is a mathematical sentence that compares two unequal quantities. Okay, you can kind of see it in the word inequality. You can think of it, they're unequal, they're unequal. So it's not an equation, it's actually comparing two things that are not equal. So we can say 5 is greater than 3, or 20 is less than 100. So we have a few additional symbols to add to what we already know. We already know how to write is less than. Okay, we can write it with this sign. An example might be 8 is less than 10. We also know is greater than, which we use this sign for, and an example of that might be 12 is greater than 2. So now we have two additional symbols and words that you may not have heard of before. That is less than or equal to, and is greater than or equal to. So these less than or equal to sign looks like is less than, and then you have a line underneath. That's how I kind of remember that, we say is less than or equal to. It also has that or equal to sign underneath. And we have is greater than or equal to. And an example of that might be 1 is less than or equal to 3. Or you could also write 3 is less than or equal to 3. Those are both true statements because as long as it's less than or equal to exactly how the words state it, then that's a true statement. Similarly, 2 is greater than or equal to 2, and 2 is also greater than or equal to 1. And both of those are true statements as well. Numbers that can make the statement true are called solutions. So this is very similar to when we studied equations and true equations like we talked about before. So the first lesson kind of just gives us some choices. Of the numbers 6, 7, or 8, which one is a solution of the inequality f plus 2 is less than 9? Now when we solve these as equations, okay, if we had the equation f plus 2 equals 9, we would have said that 7 plus 2 is equal to 9. So your first thought might be that 7 is the correct answer to this problem, but you have to be careful because 7 isn't the correct answer to this problem. Now that we have an inequality sign, we're comparing, we need something plus 2 that's going to give us an answer less than 9. So let's take a look at all three of these options. We have 6 plus 2 is less than 9, 7 plus 2 is less than 9, or 8 plus 2 is less than 9. So just like equations, we're going to solve both sides of our inequality. Okay, so 6 plus 2 gives me 8 is less than 9, 7 plus 2 gives me 9 is less than 9, and 8 plus 2, 10 is less than 9. Now, only one of these statements is true. 9 is not less than 9. 9 is equal to 9, so that's a false statement. We can cancel that out. 10 is also not less than 9. 8 is less than 9. So of the numbers 6, 7, or 8, which is a solution, the only solution that would work would be 6. So you have to be careful that we're solving these as inequalities and not as equations. I know we're used to that from last chapter, but we don't want to make those mistakes. Is the given value a solution of the inequality? So now it's going to give us a value. We have to either say yes or no. So x plus 3 is greater than 9. Well, it's telling us x is equal to 4. So if we plug that into our inequality, we get 4 plus 3 is greater than 9. And again, we can just solve both sides of our inequality. So 4 plus 3 is 7. We get the inequality 7 is greater than 9. Well, 7 is not greater than 9. So this is a false statement, and the answer would be no, it is not a solution. Very similarly to equations, inequalities can be solved. We can find a solution. And actually, instead of one solution, we get a set of solutions. And I'll explain that more in a minute. But instead of an equal sign, we're simply using our inequality symbol. So whether that's less than, greater than, less than or equal to, or greater than or equal to, we're using the exact same steps exactly as we would have solved them if they were equations. So the first one, we have 5x is less than 45. 5 times x, okay, it's right next to the x, that means times. So we want to get the variable by itself. We want to isolate that variable. So if we want to undo the times 5, we're going to divide by 5 on both sides. 5 divided by 5 is going to cancel out, and we're left with x is less than 9. So any number that is less than 9 is going to be a solution to this inequality. Okay, 5 times 8, for example, that would give us 40. 40 is less than 45. 9 actually does not work for a solution here. It has to be less than 9 because 9 times 5 would give us 45, and 45 is not less than 45 if we would plug that back into our equation. So when you're using the check step for this, you actually want to choose a number that is less than 9, since that's what our solution says. So if we plug it back in, 5 times some number, you want to plug in a number for x that's less than 9. So that can be, 0, 5, 6, 7, 8, negative 24, whatever number you want to use that is less than 9. So I'm going to use 3. So 5 times 3 is 15, and 15 is less than 45. So that is a true statement. I know that I have solved my inequality correctly. So go ahead and try to solve the rest of the 3 inequalities on this page using your inverse operation steps, and pick a number to plug back into your equation to solve to make sure that you've done your steps correctly. For the second one, you want to subtract 7 from both sides, and you get the solution x is greater than or equal to 3. So in this case, you actually can choose 3 to plug back into your equation because you get the statement 10 is greater than or equal to 10, and 10 is obviously equal to 10, so that works. So x is greater than or equal to 3 is your solution. X minus 3, we want to add 3 to both sides. That cancels out, and we're left with x is less than or equal to 12. So I could plug in 12 for my x, or I could plug in a number less than 12. So if I want to do 10 minus 3 is less than or equal to 9, that gives me 7 is less than or equal to 9, and that is a true statement. So I know this is a good solution. Okay. Remember that your division sign can also be seen as a fraction bar. So in this example, if you'd like to rewrite it using a division sign, if that's easier for you to see, you're more than welcome to do so. So in order to get rid of that divided by 8, we want to multiply by 8 on both sides. This cancels out, and we get a solution of x is greater than 24. So if we go into check, we have to make sure that we use a number bigger than 24. We can't use 24. So we'd have to use 25, 26, so on and so forth. I'm going to use a number that's easily divisible by 8, since that's my operation that I'm using. So the next number bigger than 24 that's divisible by 8 would probably be 32. So 32 divided by 8 has to be greater than 3. And since 32 divided by 8 is 4, 4 is greater than 3, that works. This is confusing to a lot of students because you can't check it exactly like you could an equation, but with more practice and just more exposure to these types of problems, they'll get easier for us. So go ahead, on the back of your notes, you're going to have 18 different examples. I'd like you to solve them, showing your work exactly as we showed our work for solving one-step equations.